Okay, tonight we're talking about relational multiplication. We've already talked about relational division, and we're going to take a step back and go over this. This may be blindingly obvious for some of you, and for some of you, you may not have ever thought of it before. So,
Might I add that you're incredibly perky
I'm
with
perky?
considering the late night. I mean, we are midnight DBA for a reason, and
Yeah, well, sorry to be so perky, everybody. I apologize. We've already created a couple of temp tables, column 1 with an identity and a couple column 2s, tables X and Y. We'll go ahead and show you the magnificent data that I loaded in there earlier. Yay. Okay. All right, let's start off talking about cross joins. Cross joins are relational multiplication. When you do a cross join, you're taking every row in your first table and matching it, or pairing it, I should say, with every row in your second table, regardless of whether or not they match. And that, of course, winds up meaning that every row in the second table is also paired to every row in the first table.
very few cases for something like that, aren't there?
Very few cases, but, you know, it comes up. But we're going to talk about it anyway because cross joins are the very definition of relational multiplication. When you do this, every row to every row, you wind up with x times y rows. In this case, we've got what, three and 7 rows. So come in here with a cross join, and that's not F5. That's F5. Voila, we come up with 21 rows. Hooray! Very simple, very easy. As it turns out, though, all joins, outer and inner, are still multiplication, a relational multiplication. It's not as obvious, so we'll go through it a little bit. The full outer join, as many of you know, I say as many of you know, full outer join means we're including all the rows from each table, even if they don't match. Now this is still multiplying. We're going to use our standard select from X full outer join Y, and then we'll match column 1, X column 1 to X column Y column 1. Excuse me, and we're going to get 7 rows. So at a minimum, this is multiplication of X rows times 1.
No. Is there a way, because up there you just multiplied the number of rows by the number of rows to get
Right.
the cross
total.
join, the cross
Sure.
join to get the total? Is there a way to estimate the total here, or to pretty much bang it out?
Well, in the case of a full outer join where you've got your comparison, your join is on an equal, then it's going to be the greater of the number of rows from the greater of the two tables times 1. That's your multiplication. And from here on out, the math gets...
What?
Okay, you've got 2 tables, one of them is bigger.
Yeah, I get that part.
Right. So whichever one is bigger, it's that many rows times 1, because you're doing on equals.
So that many rows times 1, can't we just say it's that many rows?
Well, we're discussing the multiplication aspect of it,
Oh, I
and it
see.
gets
We're
more
getting-
complicated. Now, let's say, I'm not sure if I can actually do the XY math from here on out, but let's change this to show that we're definitely doing multiplication and not just, randomly spitting rows out. We're going to change to X column 1 is less than Y column 1 and run this.
You realize I can't see you pointing at the screen, right?
Well, yeah, but they saw the less than, so I can point if I want to. Anyway,
I do that all the time.
Comes
now.
up with something different. We've come up with 10 rows now instead of 7. So we've multiplied by something else. We could sit down and we could do all the fractions and stuff, but it doesn't matter. The point is we're multiplying.
Okay.
Having proven that full outer joins are multiplication, let's go on to left and right outer joins and show pretty much the same thing.
Well, how is that proof that it's multiplication and not addition?
Well, first off, shut up. That's how I know. That's how we've proved it. But second off, we started earlier on with when we had the equals, saying that I don't want to run the whole thing. I just want to run this query. That we've multiplied everything. This is a full outer join, so we've taken the greater of the 2 tables, and that's x, and multiplied it by 1 to get 7 rows, right? Because that's how many rows we had in there.
Right.
Where's the greater than? Doesn't really matter. But we also know that we're doing the same thing that we were before. We're still doing an outer join. We're changing it a little bit. We knew that doing an outer join with an equal sign was multiplying because it's times 1. A merge would be addition. You're adding rows underneath. You're multiplying data here because you're combining it in a different way. If sometime if you guys if everybody out there is crying out for me to prove this mathematically, I can sit down and try it, but I'm really not a relational set expert. I'm just passing on just a little bit of knowledge. But we see here that for our full outer join, it demonstrates it a little bit better when you do a greater than or less than, because it's no longer times 1, now it's times something else, some other fraction.
So if I get this right, the reason we know this one is multiplication is number 1, shut up.
Yes.
And number 2, just because we changed the operator down there at the bottom doesn't mean that the operation itself changes.
Yeah, exactly. Because we're doing the same thing.
Yeah, sure.
But moving right along. Left to right outer join is very much the same thing, only this time you know what number times 1, in this case, because we've got an equal sign. Which number times 1. So right now we're joining, we're on here we go, left outer join. X is our left-hand column, so we're going to come up with 7 rows, I think. Yeah, there you go. If we were going to change this to a right outer join, we're doing the number of rows in Y times 1, which is 3. And again, change the operator. Let's go ahead and go with greater than or equal to. You're going to come up with a different number. It's still multiplication. You're still joining this data with this data and coming up with a longer list. Now, when I first started thinking about inner join, and now how on earth is that still multiplication, because you come up with a lot fewer rows in that case. That's where you start thinking about it, and it's like, oh, okay, I can see that. An inner join is still multiplication, but the thing is that you are multiplying a subset of your table with potentially a subset of the other table, and coming up with.
Yeah, sure.
So it winds up being the exact same thing. This is getting a little repetitive, and I apologize, but I really like to hammer these things into the ground if I possibly can. So before we multiplied to find which columns matched, and now we're gonna, or which column 1 to column. I'm confusing myself.
Table 1 to
table 2. Yeah, we're equal, and now we're gonna do again greater than or equal to, and you get a longer list. So really, that's about it. It's kind of a simple little thing, and again, I understand that some of you are going blah blah old news, and some of us haven't really thought of this before. But
well, and this is really all theory. One of the things that I had a hard time with when I first started doing this was figuring out which table to actually do the select from, the initial select from. I for some reason I thought it was all the same, and I would end up with I would have 10 servers. I had a servers table and a databases table, right? And I would be trying to come up with a list of servers in their databases. And what I ended up doing was getting a list of databases with their servers. So I would end up with 1,000 rows where I only meant to have 10 before. And so I mean, this is the high level, almost spirituality of it all, right? And it's really hard to transfer this into practical terms.
Yes and no. It's another brick in the wall, so to speak, of knowledge. It's probably a really bad metaphor.
Roger Waters now?
Yeah, well, but basically, the more you get to understand the details, the high-end theory, the more you do wind up being able to, either intuitively or logically, understand what it is you need. Yeah, I understand that to look at this and go, ooh, yay, it's math, isn't necessarily something to throw a big party about. But understanding that you're multiplying data, that you're going to come up with potentially more rows. It's one of the things that helps you think through when you've got a problem like that and say, okay, I've got, what do I really need here? I need a list of, what were you saying? You needed databases on servers?
Yeah.
It does help you think through that problem a little bit more logically. And again, this is but one brick in the wall. You get a whole bunch of other things that start fitting into place. You eventually start coming to a greater understanding. That's the idea, anyway.
I see. Okay, cool. So, do you think there's any way we could start seeing some practical examples of this in the future? Not right this second. I don't.
Yeah, I'd be more than happy to put together a practical something or other.
You'd be more than happy?
More than happy.
What exactly is more than happy?
Yeah, that's another podcast. Okay, so that's relational multiplication. Or that's what it is, anyway. And that's all I got.
All right, party on Wayne.
Party on Garth.